All right. This one here, I'm thinking my first instinct is just to try u sub because I can see the derivative of the bottom is going to give me the top. So again, I'm going to choose u squared, not u. U squared, that's 1 plus 3x squared, and then 2u du equals 6x dx. There's your x dx. But you can see we don't have a 6, so you would have divided that out. That gives you a third. 1 on 3 u du equals x dx. And then, of course, you already know the bottom is just going to be u. So it looks like the answer to this one is x dx is a third u du, so 1/3 integral u du on, and then that becomes square root of u squared. That cancels out, that cancels out. So it's just integrating du. The integral of du is u, right? The integral of just 1 du is just increase it by 1. So u plus c. So the answer we're looking for is square root, because u would be square root of 1 plus 3x squared on 3 plus c. Any questions?
What if you let u equals x?
U equals to x?
Yeah.
No, you wouldn't have gone anywhere, because then you would have got du equals to dx.
Yeah.
And then
okay.
all you would have written is literally the exact same expression, except it would have looked like this.
Right.
Is that right? Is that what you pretty much wrote? U squared.
Yes.
Yeah, it's not going to get you very far, is it?
No.
So the problem with what I guess, again, just to make you guys understand the idea with substitution, it's not so much about the substitution. It's about the derivative of the substitution. So when you're going to differentiate your x, it's just dx, which is useless. Whereas when I differentiate 3x squared, the derivative of that is x dx, which is the top. You understand? You know? And then the idea is adding the 1, well, it's not going to do nothing to your derivative, so you might as well. Adding the squared is just going to make your derivatives a little bit easier, so you might as well. All right. All good. All good. Next one. Tan. Oh, interesting. Interesting. Integral of tan. Okay, what did some of you guys write? Let's see who got this out. Integral of tan.
Is it
Wow.
sec10?
Sec tan.
Or is that the other way around?
I think it's the other way around. So it's good that you've memorized that. I know. It's okay. The integral of sec tan, I think, is sec. If I'm not wrong, is it? Yeah, the integral of sec tan should be sec.
Okay.
So you're close. You're on the right idea, but it's not. Yeah, no, not this one. Tan. Anyone else got anything differently? Or how'd you do it? Come on, Queenie, Azra, what'd you guys do? Tan x. What did we do? Azra, what'd you do? You tell me. What was your thinking for this? Why are we quiet? Queenie, what'd you get for this? Or how did you do it? I don't care about the answer. What was your first step?
I skipped the question.
Skipped, fair enough. Rosemary. Mariette, same thing. What did you girls do?
I didn't know, so I skipped it. And Azra's mic isn't working again.
Okay, fair enough. Skipped it. Well, okay. Tan. What do we know tan x is? Basic year 11 stuff. What are we going to change tan to?
Sine on cos.
Boom, boom. Sine x on cos x. And then, what do we realize? Well, we kind of know that the derivative of cos, right? Because they're related somehow. We know the derivative of cos, the derivative of cos going down is negative sine, which is the top. It's not negative, I know it's positive, but we can adjust for that. So technically, what is this? Technically, from what I've just said, the derivative, what would you guys say it is now?
Negative ln cos.
Ah, it's a log. Negative ln cos x.
Yeah.
So it's interesting because the integral of a trig is the log function. And then you just sub in pi on 4 and 0. Which I'm sure is pretty straightforward for us all. So the trick to that one would have been knowing that. The tan, sine over cos. Again, we've done this. It's just a matter of you guys going back and studying it. And I get it. I know you guys are not doing this at school, which is why you keep forgetting. But there has to be a point where you guys realize, okay, I've got to give 1 hour of my time to go back over extension 2. It's not that it's going to have any issues. I mean, at least this way next year, you guys, when you go, sine and cos, you'll straight away know it's a log because your brain's already started to think like that. But it'll be nicer to get it out this year. Anyways, all good, sub it in, you should be done. There shouldn't be any problems. I'm guessing no one got this one out. So that's bad, that's a 0. 1 over x squared plus 1, did we realize what this one is? This would be a partial fraction question. If it's linear, you write a constant. If it's a non-reducible quadratic, we write bx plus c. Right, we write a linear. And then we do what we used to. 1 equals a times this plus bx plus c times this. Then we usually let this bit equal to 0 or find a value where equal to 0. So in this case, let x equal to 0. That's all gone. 0 plus 1 is 1. I think we get a equals to 1. At this stage, I usually would do equate coefficients of, probably x squared. There's no x squares here. There's an a here. There's a b here. A is 1, that means b equals -1. And then we just want to find c now. So equate again. Equate coefficients of x. There's no x here, 0. There's no x here, so it's still 0. And then the only x you're going to get here is c. So that was pretty easy. C would just equal to 0. And then once we've got that, it's just a matter of substituting it back in and finishing it off. So for c, the integral is 1 on x. And then b is minus 1 on, because c is 0, on x squared plus 1. And then at this stage, if we've learned what partial fractions usually become, this becomes a log. This becomes an inverse tan. Plus c. Anyone actually get it out all the way? For 3 marks?
I got it.
Ooh, fancy. I like it. So you recognize that. That's fantastic. So pretty much, I guess, Queenie, you can say partial fractions, tick. I'm done with that. So you wouldn't need to revise it as often as you would, let's say, I don't know, just basic substitution or this one's a very specific. So tan will be done like this. Cot, exactly the same. It's cos over sine, but it still becomes a log. Sine, cos are easy. Sec x, you have to do that trick, which I'm sure you guys have forgotten. But sec is, you got to multiply it by sec tan, and then it still becomes a log. But yeah, you guys got to revise. You probably have to. I can see. I feel like I'm getting closer and closer each week. If I keep seeing the results like this, I might have to just start again, and we'll go back over again from beginning. And then I think I can just see you guys need probably 2 or 3 lessons of revision, and then we should be back to normal. But anyways, that's good. C, Queenie got it out. Well done. T formula. the most important thing for me here is not knowing that anyone got the answer out. It's knowing that you guys were able to find the derivative. So that's the most important thing for me for this, because that's a stock standard question. So I need to know that, I guess I need to know who couldn't get this bit out. So you had to find dx. You got to inverse tan, because you're not going to differentiate this, because you just learned, like, you're not going to differentiate this. It's not correct. So what you're going to do, you're going to inverse tan. You're going to multiply by 2. You always end up with this. That's just, right? You will always end up with that. And then the derivative of x would be dx, 1 dx. Derivative of this becomes 2 on inverse tan. If you're differentiating, it goes back into this form. 1 over, x squared plus 1, or 1 plus t squared, whatever you want.
Sam,
And
as
then
we
dt.
were
Yep.
asking if
Yes.
negative ln 1 plus x squared, like, isn't it negative ln 1 plus x squared, not inverse tan?
This one here, 1 on x squared plus 1.
Yeah, I think so.
No, it shouldn't. Because what's a derivative? Well, you can help us out. What's the definition for it to become a log? What's the definition for an integral to become a log? Can someone else help remind us what the definition would be?
The
The
top has to
square
be
root
the
of t
derivative.
squared. Okay, never mind.
Yeah, cool.
Yeah, okay.
The top, I think, Anouk just said it in basic layman terms, perfect. Don't complicate it. The top has to be the derivative of the bottom. That's it. Simple, which is exactly what I would have said. The top has to be the derivative. Now, if there was a number that was different, a constant, we can fix constants, but the powers have to at least be the same. So the derivative would be 2x. If that was a 3x, then it would be a log. So it has to be the derivative, whereas that's just a 2x, so no.
She said like with a half in front of the ln.
A half. Was this meant to be 1 on 2? Half in front of the ln. Oh, for this one, is she talking about? 1 on
Yeah.
x plus 1. No, the only time it would be a half is this case. I think that's what she's trying to refer to. What's the derivative of the bottom? 2x. You have an x. How do I make a 2 into a 1x? You make it a half log x squared plus 1. She's probably mixing the two because of her year 12 stuff. That's probably what they're doing right now at school, I'm assuming. Azra, if I'm right. Just careful. That's an inverse tan. Because it doesn't flow through our formula for a log. Okay. Hopefully that answers her question. Thank you, Maya, for letting me know. So we've got dx2 dt. Okay, at this stage, I need to know who didn't get these 3 lines out pretty much for D. Anyone not get this out?
Me.
Not yet, just one. Anybody else? Okay. So, not yet, I need you to memorize this. Keep writing it again and again and again.
I didn't get up to the question, so
Oh, okay. So you just got up to C and that's it? You didn't do D or
Yeah.
E? Okay. Okay, but still, would you have known how to do this T formula? T equals tan x on 2?
I remember the triangle.
Yeah, that's going to come soon. That's for sine x. But to find dx, you have to actually first find x as a subject. There it is. Inverse times 2. Then differentiate. Otherwise, without this line here, especially this dx, you guys won't be able to remove dx from the original expression. So these 3 lines need to be memorized. Or eventually, I would say just that and that needs to be memorized. If you've done it like if you guys repeat 10 questions, this exact question 10 times, I can promise you your brain will just automatically memorize it, whether you like it or not. 10 times, it'll just memorize it. So please do that. Next, dx. Dx is, I haven't changed my limits yet, but dx is 2 dt on 1 plus t squared. Divide 1 plus sine. I'm sure we've memorized our triangles, so that should be opposite over hypotenuse. The only thing I need to do is when x equals pi on 2, x equals 0, I have to actually find t. So t equals to tan 90 on 2, which is tan 45, that's 1. Tan 0, tan 0 is 0. I'll pause there. Any questions? All right, done. Let's go to the next one. So, integral 0, 1, 2 dt on 1 plus t squared, common denominator and multiply. So, common denominator and cross multiply. So 1 plus, sorry, reciprocal. And then common denominator, 1 plus t squared plus 2t. So, common, multiply that and then flip everything. Cross, cross. And then we're at the finishing touches. Any questions at this stage? That becomes a perfect square. And then that's just normal integration now. So 2, it's normal integration. Because it's not attached to anything else, so it's not a inverse tan or anything like that. Just bring it up, dt, and finish it off. 2, open bracket, t plus 1. You add 1 to the power, over the power, 0 and 1. And then 1 plus 1 is 2. So that becomes negative 1 over 2 minus t plus 1 is 0 plus 1 is 1. 1 over negative 1 is negative 1. So 1 minus half is half times 2. The answer is just a simple 1. After all that working out, the answer is 1. Usually the case for most HSC questions. They're meant to work nicely. All right. Any questions at this stage? No. All right, let's do this last one. Let's try this last one.
Sam, as you sent her reasoning for that thing before.
Okay, let's have a look. Using partial fractions. X. Oh, did I make a mistake? Is the top X? B plus CX. Hold on. Yeah, that's because it's an X, but I didn't have an X, so that means you're saying I've made a mistake in my partial fractions here. 1 a plus bx plus c. Bx plus c times x. Yep. A times x squared plus 1. Yep. Equals to 1. Yep. Let x equal to 1. Sorry, let x equal to 0. 0 plus 1 is 1. 1 times a is a. Then anything times 0 is 0. So a equals to 1. Okay, that's right. Equate coefficients of x squared. All right, this is 0 equals a plus b. A is -1. Oh, x. I full missed that x. Did I just write -1? Oh. All right. It's not so much that this becomes a log. It's that I did a mistake here. This is bx. I just wrote -1. X. If it's obviously x now, which means it is this, it becomes a log. So -1/2 log x squared plus 1. So hopefully that clears it up. It's not so much that, it's more I did a mistake up here. I'm just writing that. Is that all right with all of you? X, that has an x, my bad. I didn't see the x there.
Wait, Sam.
Yes.
Does that mean I get no marks for it?
Did you get inverse tan of x? Yes.
Yeah.
You get 2 out of 3. So you must have had the 1. You probably did the same mistake I did.
Yeah.
Yeah. -1, and then there's an x still there. So exactly the same. It's just log x minus half log x squared plus 1. Thank you, Ezra. Where was I? D. E. E. Let's try this one. Okay. E. dx on 1 plus root x. Integral of dx on 1 plus root x. What would I have done here? I would have root 1 plus root x. I probably would have done a u sub. No. Give me 1 second there, please. I'm just trying to get one particular student sorted out real quick. Okay, let's go back to this. So this one, u 1 plus root x. What would I have done? Let me think. If I had done a u sub, right? The problem is the derivative of this is not going to work very nicely, right? So I think we can agree with that. And you can see, even myself, you got to think about it a little bit. This, if I said u squared equals to x, then at least I can get the derivative, 2u du equals dx. Right? And then maybe from there I've got my dx out. So let me play everything and see what happens. 2u du on 1. And you can see the 1 plus, if I had done that, that would have been annoying because then I had to actually differentiate the root. Whereas if I ignored the 1, like you guys can see I did, what he allowed me to do was actually use u squared. So it makes it a bit easier to differentiate. All right, 2, and then I get what? 1 plus u. Yep, I think we got it. All right, all good. So now I take the 2 out. I've got u du, 1 plus u. All right, let's try to see if you can remember what I'm meant to do, or what the trick is if these were the same. So if the powers were the same, what do we do then?
Plus 1 minus 1.
Ah, you know that one. Plus 1 minus 1. So then you get u plus 1 minus 1 over 1 plus u du. Break it up. So that becomes 1 plus u on 1 plus u minus 1 on 1 plus u. Next line. That just becomes 1. That leave it the same because it's just a log. What's the derivative of u? It is a 1. And I think we're pretty much done. The answer is u minus log 1 plus u plus c. Actually, you're not done because u equals to root x. Don't forget to always substitute back. So 2 root x minus log 1 plus root x plus c. So that was a bit of a different, I guess, question you could say, which required 2 such rules, which usually is the case for those last ones. All right. Ask me any questions. I'm just going to stop the recording.